Hi everyone, for this question given that the position vector for PQR. So indirectly this question want to tell you that OP, which is your position vector, then OQ is a position vector, OR is your position vector, is given by this vector PQR respectively. So OP will be equals to the vector of P, which is 2, 1, 1. Then OQ is represented by vector Q, which is in the question here is 1, 0, negative 2k. And OR represented by the vector R, which is 3, 1, negative 1. So for this position vector, we're going to answer question A. Find vector P to R in the term of ijk. So PR can be obtained by PO plus OR. PO and OP, you can see the point direction here is opposite. Therefore, the vector here will be in negative vector. Meanwhile, OR will be 3, 1, negative 1. Simplify this, we can get 1 and then 0 and then negative 2. But this answer must be in term of ijk, so we write it to 1i, 0j, and then negative 2k. Then for question B, they ask find the Cartesian equation of the plane, which containing, so this is your plane, which containing the vector we already done from P to R, and it is perpendicular with another plane. So when you have perpendicular to another plane here, means that this plane is standing on your plane. So perpendicular to another plane. So this plane having R dot 1, 3, negative 1 equals to 7. So from this plane equation, we can take out normal. So this plane equation normal will be 1, 3, negative 1. So where's the normal for this plane? It will be come out perpendicularly from this surface, from this plane. So here will be our normal vector, which is 1, 3, negative 1. So this is the information hidden in this plane equation. Come back to the question. When we want equation of the plane, means we need to find the equation using r dot n equals to a dot n. So what is the a and what is the normal that we need to find here? A will be a position vector for the point. So since we have point P and point R on the plane, so A can be vector P or can be position vector for this point R, vector R. So we have two options to choose, whether you choose position vector for point P or position vector for point R, which is these 2 points which is on your plane. Then we need to find the normal. So the normal here will be the vector which is coming up perpendicularly from this surface. So how to get this normal vector direction? As you can see, we have two vectors crossing each other. One is vector PR, one is vector normal. So when we have two vector A and vector B crossing each other, you can build out a normal vector, which is your A cross B. Therefore, for this surface, we want to find the normal vector. It can be obtained by using vector PR cross with the normal vector that come up from this perpendicular plane. So to do this cross product, you need determinant 3 by 3 with the first row is ijk, and then we put in the vector of PR, which is 1, 0, negative 2, and then put in the normal vector from this perpendicular plane, which is 1, 3, negative 1. Then we start doing this determinant, which is you need minor I, minor A12 for J plus minor A13 for K. So how to get this minor will be eliminate first row first column, we give us 0, -2, 3, -1. So directly use -2, -1 to the second minor, then 0, 3 to the last minor here. Vertically, you have 1, 1. Now we're going to simplify this minor, which is AD minus BC, A times D minus B times C. So for this case, it will give you 6i and then minus j plus 3k. So once we get our normal vector and position vector for this plane, we can continue to our equation of plane, which is r dot n equals to a dot n. So r, we're going to substitute x, y, z, as this question asks us to find the equation of the plane in Cartesian form. So n here will be 6, -1, 3 equals to position vector. So either one point to be used, whether point P or point R. So we just select one. So we just select point P. Let's say point P is 2, 1, 1. Position vector for point P, 2, 1, 1. Then dot with normal, 6, -1, 3. So dot product will be x times x plus y times y, z times z. So here we'll give you 6x minus y plus 3z equals to here. We give you 12 minus 1 plus 3. Simplify your answer. At the right hand side here, we give you 14. So this is Cartesian equation of the plane. Then continue. For the question C, they ask you to find the angle between a vector and the plane. So position vector OQ. So let's say this is a plane that mentioned here, which is 2x minus 3y minus z equals to 6. And a vector of point OQ. So let's say this is a vector OQ. So to find the angle between this vector and plane, we need the formula angle, where formula angle is cos theta equals to A dot B over magnitude A, magnitude B, where vector A will be the first vector in this direction and vector B will be second vector in another direction. So here will be the angle enclosed by these two vectors. We need to find this pattern in finding our questions. So in plane equation, we can take out information where 2, -3, -1 means this having a normal coming out from the plane. So the normal coming out from the plane is 2, -3, and -1. So the angle between plane and the vector here. So you want to find this angle. So this is the angle between the line and the plane. But what can you use? The formula here is we are finding this angle first. So cos alpha, I put this angle as alpha, will be vector OQ dot with vector n over magnitude OQ and magnitude of the normal. So vector OQ, it is given, which is 1, 0, -2. Vector normal from the plane, 2, -3, -1. Over magnitude means square root x squared, y squared, and z squared. Magnitude n, x squared, y squared, and z squared. So here it will give you 4 over square root 5 and square root 14. So move your cos to the right hand side. Here we get our alpha, which is 61.44. 61.44 only is the angle between the normal and vector OQ. So it's not yet the vector OQ and the plane. So when we highlight this place, alpha here, in opposite here also alpha. And then you can see a triangle here. This is 90 degree. So lastly, this is the angle that we want. This is the angle that we find from alpha. And since this vector n is normal, means it is perpendicular come up from the plane. So to get the angle that we want, so 180 in the triangle, 180 minus 90, then minus alpha. So lastly it will be 90 minus alpha, which is 61.44. So here will be the angle is for the vector OQ and the plane. So this concept is similar with the concept angle between a line and a plane. Because when we're doing the angle of a line, what we take here is a direction vector of the line. So that's all for this.